Welcome back, Math 10. Today we're going to look at trigonometric ratios on a calculator, and we're also going to delve deeper into some patterns with trigonometry. Okay, so to warm up, let's look at Sohcahtoa. What does Sohcahtoa mean again? So stands for opposite, which is the sine, opposite over hypotenuse. Cosine, ka, is adjacent over hypotenuse, and tangent, tan, or toa, is opposite over adjacent. So, now if I have two different sized triangles, but all the angles are the same, will the ratios be different? I want you to think about this and answer. Remember from yesterday, if I have two different sized triangles, okay, but all the angles are the same, will the ratios, the Sohcahtoa ratios, be different? Yes or no? And why? Okay? Now, we're going to learn how to use a calculator here. Okay? So which angle does 35 represent? Well, in this one here, it represents this angle right here, which is angle A. Okay? So I'm just going to put angle A, or we could write angle A. Okay? So then, if we did sine 35, what ratio are we trying to figure out? If we're doing sine 35, we're trying to find out sine is opposite A over C. We're trying to find out the ratio of side A over C, which is opposite over hypotenuse. Okay? That is the ratio we're trying to figure out. Now, in our calculator, we're going to just type in sine 35. This will give us our ratio without knowing any of the sine legs, which is really neat. So, first of all, I'm going to put on my calculator, clear it. I'm going to have to go to my mode. Okay? And I want to make sure my calculator is in degrees. If it's in radians, so if the radian's highlighted, we have to go over and put it into degrees. Okay? We won't be using radians until grade 12 more, and maybe a little bit in grade 11. So let's take a look at this now. We just have to put in sine, which is right there. Okay? And then we're going to punch 35 and enter. I get 0.57. That's my ratio. So my ratio is 0.57, and that's it. Okay, so what about cos 35? What is the ratio of this telling us? Well, cos 35 is telling us, well, B, the adjacent, over the hypotenuse. So B over C. My ratio of B over C, side B over C, which is adjacent over hypotenuse. So cos 35 degrees is equal to, all we have to do is type in cos 35, and I get 81.9, or 0.819, which is 0.82. That is my ratio of my B divided by my C. My ratio of A divided by B is 0.57. Okay? There we go. So let's try my next question. So first example here. Use a calculator to determine each of the value to 4 decimal places. Well, I already did sine 35. That is equal to 0.5736. Now I have to round this up because 0 to 4, leave as before, 5 to 9, move up the line. Okay? Now let's take a look at number 2, sine 58. So we're going to have to punch that in. We're going to go sine, hit that sine button right there. Okay? Sine 58. And I get 0.8480. Okay? Let's take a look at my next one. We want cosine of 55. Okay? So we want cosine 55. So I'm going to hit cos 50 or 35. 35. Almost put in the wrong one. Good thing I read it again. I'm going to get 0.8192. Okay? And then we're going to want cosine 58. So I push cos 58, and I get 0.5299. Okay? There we go. Let's take a look at my next question. So in class example number 2, we have two triangles, triangle 1 and triangle 2. One has an angle of 35, angle 58. So it's angle AOB, so we go from A to O to B, okay? A to O to B increases from 35 to 58 degrees. Explain using Sohcahtoa why the sine ratio increases and the cosine ratio decreases. So I look at this, what has happened as I go from 35 degrees to 58 degrees. What is happening here? Okay? Well, my opposite is getting bigger. My hypotenuse is staying the same as 1. So using sine, if I use sine, it's opposite over hypotenuse. The hypotenuse is staying the same. Right? But my opposite is getting bigger. It's growing. So this one here is increasing. Therefore, what's happening is if my ratio will increase. Thus, my ratio increases. Since the opposite is increasing, opposite is increasing in length, and the hypotenuse is staying the same, which is my new denominator, stays the same, my sine is increasing. My sine ratio increases. Okay? Now let's take a look at cosine. Cosine is equal to adjacent over hypotenuse. Now the adjacent is the one, remember, on the angle. What's happening to that cosine? Well, from here we're going long, then we're getting shorter. As we go up, it's getting shorter and shorter and shorter. We're getting closer. Think of it as you're looking at the building. Far away, the building looks small. As we get closer, it looks like it's getting bigger, and we have to look up more, right? As we get closer. So that's why the sine, the opposite, as this angle increases, the opposite gets bigger, but my adjacent gets smaller, okay? Because we have to get closer. So basically, the adjacent decreases and the hypotenuse stays the same, okay? Therefore, what's going to happen is my adjacent, my cosine will, because adjacent decreases, hypotenuse stays the same, so therefore my cosine will decrease. Thus, cosine decreases. My cosine ratio, decreases as the angle increases. Now if we look the other way, as the angle decreases, my cosine will increase, right? If we're going this way, as the angle goes down, we run farther away, I don't have to look up as much. The angle is less, right? But my cosine will now increase because my distance away is increased. But now my sine law will decrease. So if we get the angle smaller, sine decreases, cosine increases, okay? So if the angle's bigger, sine increases, cosine decreases. Hopefully you understand that. Okay, now let's take a look at class example number 3. Without using a calculator, state which of the following ratios will have a greater value. So we're going to look at sine 14 or sine 20. Well, I know this one here will have a bigger value because I'd have to look up more to see. 20 degrees up, I'm looking up higher. 14 degrees, I'm not looking up that high. Looking up for 20 degrees, I have to look up higher, okay? So this is going to be bigger because the opposite will be bigger. Let's take a look at cos. Cos 7 or cos 63. Well, cos 63, I'm going to have to be very close to something. So cos 7 is actually the bigger one, okay? Because we have to be farther away to, as we get closer, we're looking up so farther away, okay? Next one is tan 15 or tan 75. Now that's interesting. So tan 15 or tan 75. So tan is opposite over adjacent, okay? And here we have opposite over adjacent. So as this gets bigger, what happens? My opposite increases. As the angle gets bigger, my opposite increases and my adjacent decreases. So this gets bigger even faster. This gets really big, really, really fast. So this will get, so what's bigger is this one. This one's a lot bigger because it gets bigger really, really fast. Now let's take a look at this one. Which one gets bigger? Which one will have the greater value? Sine 80, cosine 80, or tan 80? Okay? Now what is always the biggest here? My hypotenuse is always my biggest side. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this is always my biggest side. So these are going to be smaller than this. Okay? So this here must be my biggest, I believe. Why? Because tan 80, that's a big angle. So opposite is going to be big. This is going to be small. So this is going to be big divided by small gives me big. This is going to be big. This is going to be small. This is going to be big, but this is going to be big too, but not quite as big as the hypotenuse. Therefore, my largest is this one. This is number 1 for biggest. This is going to be number 2. This is going to be number 3. Okay? Hopefully you get that. Alright, now let's take a look at example number 4. Using a calculator, determine the value of each trigonometric ratio to 4 decimal places. So I want sine 81. Calculator, I'm just going to put in, punch, let's look at my keystroke, I push sine, then I push 81. Enter. That gives me 0.9877. So we get 0.9877. Let's try tan 14. So I'm going to go tan 14. I'm going to get 0.2493. And that makes sense, because in tan 14, my adjacent is going to be big, and my opposite is going to be small. This is going to be big, this is going to be small, right? Here, when I look at this, sine 81, that's close to 90 degrees. I'm going to be looking almost straight up. So my opposite is going to be really big. So my ratio, but still going to be less than 1, is going to be big, right? Okay, it's not as big as my hypotenuse, because, okay? Let's take a look at the next one. Cosine 44. So let's plug that in. I first hit cosine, then I'm going to hit 44. And I get 0.7193. Okay? So now, let's say we know what the ratio is, but we want to find the angle. What do we do? So it's kind of like looking in the mirror and getting the wrong info, right? So, we could always guess and check on a calculator, but that will be like this dog here chasing his tail. It'll take forever. Eventually you'll get there and maybe find it, but you could spend forever guessing. Okay? So what must we do? We're going to do something a little bit different. Here's how we solve it. Here's my first hint. Okay? Think of tan as its own value. Alright? So we're going to think of tan as its own value. Once we think of tan of its own value, we want tan x is equal to 1.2. How do we solve it? Tan has its own value. So I'm going to go, then we have tan x is equal to 1.2. Then I'm going to go divide this by, both sides by tan, divide this by tan. If we think of it that way, that makes us to have x is equal to 1.2 over tan. Well, I want this with a positive exponent. So this is kind of like saying x is equal to tan to the negative 1, 1.2. So now all we have to do, because this is positive exponent, if I flip it, right, negative 1, so 1.2. So let's see what that equals to. So we're going to go tan, oops, clear. In our calculator, we're going to have to hit the second button. Then we're going to hit the tan button. And then we put 1.2. Enter. And that gives me my side. X is equal to 50.2 degrees. That gives me my angle. Sorry, not my side. My angle, which is 50.2 degrees. All right? So, here we go. Let's take a look at class example number 5. It says, determine the measure of each angle to the nearest degree. So I have sine A is equal to that. So if I want to rearrange this, it's like dividing both sides by sine, divide by sine, but we can't put that in our calculator. We can't go 0.35 divided by sine. Doesn't make sense. So we're going to put in our calculator angle A is equal to sine -1, 0.3584. Okay, so let's put that in my calculator. So we go second, then we hit the sine button, okay, and we put 0.3584. Enter. I get 21 degrees, which is equal to 21 degrees. Let's try the next one. So the next one here, we want B is equal to cos, the inverse of cos, and we want 0.5389. Let's try that out. So I'm going to go second cos, 0.5389. Enter. I end up getting 57 degrees. So we get this is equal to 57 degrees. Now we want tan. So we want P. So angle P is equal to tan 3.2106. Notice tan is the only one where we could be bigger than 1. Because we could actually have my opposite being bigger than my hypotenuse. Or, sorry, my opposite being bigger than my adjacent. But when we're looking at sine, cosine, our opposite or adjacent cannot be bigger than the hypotenuse because the hypotenuse is the longest one. So those are all going to be less than 1. But this one could be bigger. So we go second tan, right? And we go 3.2106. And I hit enter. I'm going to get 73 degrees. And the last one, we have C is equal to sine -1. We're going to put that 1 over 2. So let's try that out. So I'm going to go second sine, okay, right? And then we have 1 divided by 2, bracket, which is 0.5. I can put that instead, but make sure I close my brackets. I get 30 degrees. All right? Pretty simple. Okay, so now, without using a calculator, determine sine 0 degrees and sine 90 degrees. Well, if I have 0 degrees, it's going to look like this. It's just a straight line. My hypotenuse is going to be 1. Well, and this is going to be 0 from the ground. Doesn't matter what my hypotenuse, if it's 1 or a million, it's going to be 0 because there's no elevation, 0 over my hypotenuse. So it doesn't matter what my hypotenuse is, it's going to be 0. Okay? It's going to be 0. Now let's look at sine 90. 90, remember, sine is opposite over hypotenuse. Well, that's a straight up and down. 90 degrees is straight up and down. Well, I look at this, my hypotenuse is going to be the same thing as my vertical, which is my opposite. Right? My hypotenuse is the same as my opposite. So this is going to be opposite hypotenuse here. They're going to be equal to each other, so it's kind of like saying opposite is equal to hypotenuse. So it is like saying hypotenuse over hypotenuse, which is going to be equal to 1. So this is always equal to 1. This is always equal to 0. All right? Now, let's take a look at the next one. We want cos 0. So we're saying the same idea, right? Cos of 0. Now, it's a flat line. Well, that flat line, straight side to side, what is that? Well, my hypotenuse for cos, that's adjacent over hypotenuse. Now, I look at this. This is 0 degrees there. Okay? Think of it this way. Here's this. Keeps on going down. Some distance. Down. Down. To eventually, we get 0. Alright? They look like that. 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 So eventually we get 0, which is right there. So eventually my adjacent is actually equal to the hypotenuse. For this one, cos 0, the adjacent equals my hypotenuse. That's like saying h over h, right? Which is equal to 1. Now let's take a look at cos 90. Cos 90 is the straight up and down. So we had something that looked like this. Then we go like this. So we're eventually getting to 90. Then eventually it's straight up and down, right? So that's 90 degrees. Well, my distance side to side there is 0. So my adjacent has no sideway. So it's 0. So I'm going to get 0 over h. which is equal to 0. Doesn't matter what h is, it's going to be 0. So this one's always equal to 0, and this one's always equal to 1, that ratio. Just like this one here. Sine 0 is always equal to 0, and sine 90 is always equal to 1. Okay? Cos 0 is always equal to 1. Cos 90 is always equal to 0. If you want to do this challenge, you can continue. If not, you can finish your video and go on. So here is my challenge one. It says, draw a triangle LMN where angle L is equal to 90 degrees and N is equal to x degrees. Well, so let's draw this triangle out. I'm going to end up getting a triangle that looks something like this. 90 degrees is L, so that's L. N is going to be my x degrees, and we have M is here. Okay? Now, write an expression for angle M in terms of x. So angle M in terms of x. Well, angle M is equal to 90 degrees, because we add up all the angles of a triangle, it's equal to 180, right? So we have 190 degrees there, so then these two must add up to 90 degrees. So 9 degrees minus x will give me this one. Okay, so that's my expression for angle M. Now, in terms of x. Now, explain using ratio why sine x is equal to cos 90 minus x. Well, look at this. We have sine x, okay, is equal to, in this case, sine n, which is equal to Lm over Mn, right? Because it's equal to, sine is opposite over hypotenuse, okay? So, opposite over hypotenuse, okay? Now, we also know, now let's take a look at cos 90 minus x, is equal to cosine of m. Okay? Cos 90 minus x is equal to cosine of m. Well, what is that equal to? That's going to be this divided by that. Or sorry, this here, adjacent, divided by opposite. So we have is equal to, we have adjacent, which is ml, or ln, over mn, which is my hypotenuse. Okay? So in other words, this is the exact same thing as that. Now, complete the following. What would be sine 20 equal to in cosine? Well, all we have to do here is sine x is equal to 90 minus x. So that's going to be equal to 90 minus 20, right? Which is equal to cos 70. Let's try sine 8 is equal to 90 minus 8, which is the same as cos 82 degrees. Okay? Does that help? Hopefully you understand that. If you don't get this, don't worry, we can work on a bit more tomorrow, because these are your challenging questions. Alright? So that's everything. Hopefully you understood everything. Good luck. As I see you tomorrow, we work on this together.